Hello everyone, my name is Shubham Oli, and today I'm here to present you my unsupervised machine learning capstone project from Alma Better. And my project is Netflix movie and TV show clustering. This is my individual project. So this is our project summary. The aim of this project is to analyze the Netflix dataset of movies and TV shows until 2019, sourced from the third-party search engine Flexible. So additionally, the dataset will be analyzed to uncover insights and trends in the streaming entertainment industry. So this project followed a step-by-step process. The first step is handling null values. Then we manage the nested columns, then binning the rating attribute into categories. Then we perform exploratory data analysis. After that, we create clusters and using the attributes. These attributes were tokenized, preprocessed, and vectorized using TF-IDF vectorizer. And after that, we reduce the dimensionality of the dataset using principal component analysis. Then we have used the K-Means clustering and agglomerative hierarchical clustering algorithms. And after that, we develop a content-based recommender system. So this comprehensive analysis and recommendation system are expected to enhance user satisfaction, leading to improved retention rates for Netflix. So this is my GitHub link. This is our problem statement. So the dataset consists of TV shows and movies available on Netflix as of 2019. The dataset is collected from Flexible, which is a third-party Netflix search engine. In 2018, they released an interesting report which shows that the number of TV shows of Netflix has nearly tripled since 2010. So in this project, we are required to do exploratory data analysis, understanding what type content is available in different countries. If Netflix has been increasingly focusing on TV rather than movies in recent years, clustering similar content by matching text-based features. So these are the fields we have, and these are their descriptions, like we have show ID, type, title, and so on. So let's begin. So at first, we have to import our libraries. For data manipulation, we have used NumPy, Pandas, and Datetime. For data visualization, we have used Matplotlib, WordCloud, Seaborn, and Plotly. And also we have used sklearn library. So at first, for dataset loading, we mount our drive, and then we load the dataset. This is our first view of our dataset, and we have 7,787 rows with 12 columns. This is our dataset information. So we have not null values, and we have one integer and 11 object data types we have. And for checking for duplicate values, so we have 0 number of duplicate values in our dataset. Checking for missing or null values. So here in the director column, we have 2,389 null values, and in cast we have 718. And as we can see, we have country, date, edit, and rating. These have null values, and these are the percentage. Like the 30% of director data has null values, and 9% is in cast. Now we will visualize them for missing values. We have plotted a heat map, and here we can see the director has the maximum number of null values, and least number of null values are from rating and cast and country. Now we will again visualize, and we can see the count. So as we can see, director has the 2,389 null values, and date added has 10, rating has 7. So what did we know about our dataset? So this dataset, Netflix movies and TV shows clustering, comprises 12 columns with only one column having an integer data type. It does not contain any duplicate value, but it does have null values in 5 columns: director, cast, country, date added, and rating. So this dataset provides a valuable resource for exploring trends in the range of movies and TV shows available on Netflix. Additionally, it can be utilized for developing clustering models to categorize similar titles together based on shared attributes such as genre, country of origin, and rating. Now we will check our dataset column. So we have show ID, type, title, director, and so on. And by .describe method, we are able to see the statistical information of our dataset, but we only have a numerical value in this column, and others are object values. So we can't see any values here. Now variable description. So show ID means the unique identifier for each movie or show. Type is the type indicates whether the entry is a movie or a TV show, and we can see all rest of the details here. Now we will check for unique values for each variable. So for show ID, we have 7,787 unique values. Type has 2, title has 7,787, and so on. Now we'll do some data wrangling. So at first, we will handle the null values from each feature. So as we have seen above, the director has 2,389 null values, and cast, country, date added, and rating has 2. And these are the percentage. So we will count the values from date added, rating, and country. Since date added and rating has very less percentage of null count, so we can drop these observations to avoid any biasness in our clustering model. We cannot drop or impute any value in director and cast as the null percentage is comparatively high, and we do not know data of actual movie or TV shows. So it's better to replace these entries with unknown. We can fill null values of country with mode, as we only have 6% null values, and most of the movies shows are from US only. So here we will impute null values as per our discussion. So at first we will impute with unknown in null values of director and cast feature. So here we have filled the unknown for director and cast, and for country we have filled with mode, and after that we recheck, and also we drop the date added and rating. Okay, now next we recheck the missing and null values. So here as we can see, we have 0 number of missing or null values. Now handling nested columns that are director, cast, listed in, and country. So let's create a copy of data frame and unnest the original one. So we unnest the director column, and after that we unnested the cast column, and then we unnested listed in column, and we unnested country column. So we have successfully separated the nested columns. Now let's merge all the create data frame in the single merged data frame. So we merge the all unnested data frames, as we can see here. And now let's merge this data frame with the original one on the left join, just to avoid information loss. So here we have merged unnested data with the created data frame in order to make the final data frame. Now typecasting of attributes. So here we will check the information of our dataset. So here we have 1 integer and 10 object values. Now we typecast duration into integer by removing min and season from the end. And after we typecast string object to date time object of date added column, and we extract date, day, month, and year from date added column. And after that, we drop the date added. And now we can see we have 5 integer values and 8 object values. And now binning of rating attribute. So here we have rate like TB, MA, R, PG13, TB14, and these are the details of these ratings. But these names are quite complicated. So here we have created a new bin in which we merge the, like we have our first option, adult content. Here we have merged the TVMA, NC17, and R. And next is our children content. Here we have merged the TVPG, PG, TVG, and G. And as we can see, we have teen content, family friendly content, and not rated. So next we did the code, and we have created a new bin. So here, as we can see, the rating is changed into adult content. Now we separate movies and TV shows. So here we can see we have 1,26,079 rows with 13 columns for movies and 49,728 rows with 13 columns for TV shows. So what all manipulations we have done right now? So we have divided data wrangling into 5 different sections. So in first section, we have dropped the null values of director, cast with unknown. We imputed director and cast with unknown. We imputed country with mode, and we dropped null values of date added and rating. And next step is we have unnested values of director, cast, listed in, and country. And our third step is we have typecasted duration into integer and date added to date time. We have also extracted the following features like date from date added, month from date added, and year from date added. And also we have seen that the rating column contains various coded categories. So we have to decide it to create 5 bins and distribute the values accordingly. So we have created adult, restricted, teen, all ages, and not rated. Lastly, we have splitted the data frame into 2 DF. One is DF movies that contains only movies, and other is DF TV shows that only contains the TV shows for further analysis. Now we will do data visualization. So our first chart is the relative percentage of total number of movies and TV shows over Netflix. So here we can see the green one is for movie and yellow is for TV shows. We have 28.3% TV shows and 71.7% of movies in the Netflix. So here we can see the majority of the content on Netflix is movies, and the TV shows make remaining the 1/3 part, and 2/3 part is for movies. So the gain insight are the production house should more focus on quality movies because there is high competition in the market, and TV shows are less in numbers, hence good opportunity for business. Our next chart is how content is distributed over Netflix. So this is the overall content rating over Netflix. So we have 49.1% adult content and 29.8% of teen content, then children, family friendly, and not rated. And these are for only movies, and these only are for TV shows. And here, as we can see, the most of the content present in the Netflix belongs to the adult and teenage categories, as we can see here, 47 and 52. And another important insight, we can see that family-friendly content less in movies compared to TV shows. So here we can see this is less and this is more. And we gain the insights like for high gains, production house should more focus on teen and adult content. There is good chances of growth in family-friendly category in shows. And our third chart is what are the top actors performing in movies and TV shows. So this is for movies and this is for TV shows. As we can see, Anupam Kher is the top, then Shah Rukh Khan, then Nasiruddin Shah. And in TV shows, Takahiro Sakurai, Yuki Kazi, and Daisuke Ono are the top three. So we found an interesting insight that most of the actors are from India in movies, and no popular actors are from India in the TV shows. And we gain the insights like Indians are movie lovers. They love to watch movies, hence business should target Indian audience for movies. Next chart is who are the top directors directing movies and TV shows. So Jan Sutter is the topmost director for movies, and Ken Burns is the topmost director in TV shows. So here we can find that insights we have that can help our movie and TV shows producer can select the popular director for their upcoming projects. Our next chart is what are the top 10 countries involved in the content creation. So US is on the top, then India, and then United Kingdom. So United States is a top country producing both movies and TV shows on Netflix. This suggests that Netflix is heavily influenced by American content. India is the second highest producer of movies on Netflix, indicating the growth opportunity of Bollywood movies worldwide. Countries like Canada, France, Japan also have significant presence in the data, as we can see. So the insights gained can have a positive impact on Netflix business by highlighting opportunities for growth and expansion, such as investing in American Bollywood content and acquiring more diverse content. Now, our next chart is which countries has the highest spread of movies and TV shows over Netflix. So here we can see the blue one is for movie and red one is for TV show. So US has the most content for for movies, and for Japan and South Korea has more TV shows, as we can see. And these are the top 10 countries launching movies back to back and TV shows back to back. So both are the top one is United States for movies, second one is India, and for TV shows, United Kingdom is on the second. So India produces most amount of movies in compared to TV shows. Japan and South Korea produces more TV shows in compare of movies. So the insights gain can help positive impact on Netflix business by highlighting opportunities for growth and expansion. Our next chart is which genre are popular in Netflix. So here we can see international movies are on the top, then dramas, then comedies. And most popular genre of movies and for TV shows, international movies, dramas, comedy, and international TV shows, TV dramas, and TV comedies are on the top three. So international movie genre is most popular in both the TV shows and movie category, followed by drama and comedy. So the insights gained can have a positive impact on Netflix business by helping the platform understand what genre and types of content are popular with its audience. Our next chart is total number of movies and TV shows released and added per year on Netflix. So here we can see movie released per year and added in Netflix per year, and same as it for TV shows. So we can see number of movies and TV shows added on Netflix has been increasing steadily every year. But since 2018, the number of movies released on Netflix has been lowered and the number of TV shows released and been significantly increased, as we can see here. So our next chart is for total number of movies versus and TV shows added per month on Netflix. So for per month, like for January, October, and December, the movies are added the most, and for TV shows, the December month, and after that, January and March has the highest rate of adding the TV shows. And our next chart is for total number of movies and TV shows added per day on Netflix. So here we can see the first day and the 15th day for movies as well as for TV shows has the highest number of adding the content. And our next chart is what is the month-wise number of content added in each year on Netflix. So here, as we can see, from 2008 to 9, so in the second month, and after that it slowly increased, and here it has gone to the 10th month like this, and the 12th month, the orange color. They have there from 2018 to 20 and further. So from 2019, as we can see, the month of October has the most number of movies added, and after that, the December month. So our next chart is what is the day-wise number of content added in each year on Netflix. So from each year, so from 2015 to 2020 or 21, we can see the 30th day, the last day of the month has the most number of movies added. And also we can see the sky blue color, which is of 15th day, has the most, also the maximum number of contents added. So our next chart is what is the distribution of duration of contents over Netflix. So here, as we can see, the most of the distribution is from 80 to 120 minutes. They have the most number of distribution in the movie. And this bar plot shows the TV duration. So here we can see for movie duration in minutes on Netflix shows that the majority of movies on Netflix have a duration between 80 to 120 minutes, as we have seen here. And the count plot of the distribution TV shows, it shows the most common duration of TV shows on Netflix is 1 season followed by 2 seasons. And our next chart is the distribution of content rating in each highest content creating countries. So here we can see US has the adult content 47%, United Kingdom 58%, and India has the maximum number of teen content available. So most countries produces content related to adult and teen. Among all the countries, India has less content in adult segment than teen segment. 85% of content is adult content from Spain, as we can see here. And now we will do some hypothesis testing. So we have 3 hypothetical statements. So our first statement is our null hypothesis is there is no significant difference in the proportion ratings of drama movies and comedy movies on Netflix. And our alternative hypothesis is there is a significant difference in the proportion ratings of drama movies and comedy movies on Netflix. So we will perform an appropriate statistical test. And here we use Z statistic. We have used here Z test of proportion. So Z statistics score is 64.8%, p value is 0. It rejected the null hypothesis. So we conclude that there is a significant difference in the proportion ratings of drama movies and comedy movies on Netflix. Our second hypothetical statement, our null hypothesis is the average duration of TV shows added in the year 2020 on Netflix is not significantly different from the average duration of TV shows added in the year 2021. And our alternative hypothesis is the average duration of TV shows added in the year 2020 on Netflix is significantly different from the average duration of TV shows added in the year 2021. So again, we perform an appropriate statistical test. Here we perform a 2-sample t-test, and the t-value is -6 and p-value is 7.23. It also rejected the null hypothesis. So the average duration of TV shows added in 2020 on Netflix is significantly different from the average duration of TV shows added in 2021. So our third hypothetical statement is the null hypothesis is the proportion of TV shows added on Netflix that are produced in the United States is not significantly different from the proportion of movies added on Netflix that are produced in the US. Our alternative hypothesis, the proportion of TV shows added on Netflix that are produced in the United States is significantly different from the proportion of movies added on Netflix that are produced in the US. So here we have performed the Z test of proportion. Z statistic value is -4.83, p value is 1.31, and it also rejected the null hypothesis. So we conclude that the proportion of TV shows added on Netflix that are produced in the US is significantly different from the proportion of movies. So here, after that, we did feature engineering and data preprocessing. So since we have already dealt with the null values, so it is not needed now. And we will check the outliers. So although we have some of the anomalies in continuous feature, but we will not treat by considering outliers as some of the movies or TV shows has released or added early on Netflix. Now we'll do some textual data preprocessing. Here we are taking the copied data frame as the data having more number of observation resulted in RAM exhaustion. So we have 1,75,807 by 14 data type, but from new we have 7,770 by 12. Now binning of rating and new data frame. So here, as we can see, we check the sample of our bin after billing. Now textual columns. So here we create a new feature content detail with the help of other textual attributes. So we will check it after checking the manipulation, as we can see here. Now we'll do some lower casing. So here we did the lower casing, and after that we remove punctuations, and then we remove URL, and removing word and digit contain digits. After that we remove stop words and white spaces. Here we can see. And after that we did some tokenization. We download the needed libraries, nltk.download, unkt, and so on. After that we did the text normalization. From nltk.stem we import the wordnet lematizer. And here we have used lemmatization instead of stemming for our project because lemmatization produces a more accurate base word. It can handle different inflections. It produces real words, and it improves text understanding, and it also supports multiple languages. So after that part of speech tagging, we tokenize the text into words before POS tagging. And after that, we did text vectorization. So we have used TF-IDF vectorization in place of tag of words. After that, we did the dimensionality reduction. So here we have imported from sklearn.decomposition, we imported the principal component analysis. And here, so it is clear from the above plot that 7,770 principal component can capture the 100% of variance. For our case, we will consider only those number of PCs that can capture 95% of variance. So we have used PCA for dimensionality reduction. Now we will do the machine learning model implementation. Our first model is K-means clustering. So we iterate over a loop of 1 to 16 clusters and try to find the optimal number of clusters with elbow method. So here we have created the elbow method, and here it seems that the elbow method is forming at the 2 clusters. But before blindly believing in, let's plot one more chart. And here we have plotted a sellout score. And from the above plot, it is very clear that the sellout score is comparatively good for 4 number of clusters. So we will consider 4 number of K-means analysis. Now we'll plot and see how our data points look like. And here we can see 0, orange is 1, green is 2, and red 1 is 3. So we have 4 different clusters, but they are in 2-dimensional. Now we will plot them in 3D. So here we can see from our naked eyes, these 4 clusters. So starting with defining a function that plot a word cloud for each of the attribute in the given data frame. So here we have plotted a word cloud. So for cluster 0 in description, so the most number of word used is life, love, find. And for cluster 1, it's life, find, take, and so on, as we can see here for for country, title, and so on. Now our next model is hierarchical clustering. So let's divide it into dendrogram. And here we can see we have 2 clusters. So it is a tree-like diagram that records a sequence of merges or splits. So, and now we compute the sellout score for each K. And here, so it is clear that 2 clusters are optimal value, and which are also clear from the above dendrogram. Now let's again plot these clusters into a chart, and here we can see, and again we did in 3-dimensional. And now we again did the word cloud, and here we can see the most number for description is find, 2, family, love, life, and for cluster 1 is life, new word, and for country it is United States. Here also it is United States, Christmas, love, girl, as we can see. Now our third model, which is building a recommender system. So here we use cosine similarity over TF-IDF because it handles high dimensional sparse data better. So let's check how our recommender system is performing. So here we have searched Kal Ho Na Ho, and it has recommended other movies like Dil Chahta Hai, Kya Kehna, and so on. So it is a kind of romantic and serious movie, and these are also. And now we will check for Zombieland, and here we can see the recommended movies. The similarity score is 0.1, which is quite good. And now we check for Zindagi Gulzar Hai and so on. So we have chosen sellout score over distortion score as evaluation metrics, as it measures how well each data point in a cluster is separated from other clusters. So these are the advantages of sellout score. So we have considered K-means as our final model, as we are getting the comparatively high sellout score in K-means clustering. So also in some situations, K-means work more accurately in speed, ease of case, scalability, and independence of cluster. So our conclusion from EDA, we have discussed above, like 2/3 of content in Netflix are of movies, and 1/3 is for TV shows. Adult and teen categories are prevalent on Netflix. Indian actors dominate Netflix movies. Jen Sutter and Ken Burns are the topmost director for movie and TV shows. US has the largest producer of movies, and so on, as we can see here. And we draw the conclusion from ML model. We implemented K-means clustering and agglomerative hierarchical clustering. So the optimal number of clusters we get from K-means are 4, and hierarchical clustering are 2. And we choose sellout score as the evaluation metric. We build a recommendation system. So for future work, we can integrate this data set with external sources such as IMDb ratings, book clustering, plant-based type clustering can lead us numerous integrating discoveries. By incorporating additional data, a more comprehensive recommender system could be developed, offering enhanced recommendations to users this system could be deployed on the web or widespread usage. Thank you.